All right, so in problem number 56, the first question we have to ask is there any places where these functions are not continuous and differentiable? This is continuous and differentiable everywhere, so that can't be the answer. This is continuous and differentiable except at positive 2, which is not in our interval, so that one can't be the answer. So of the remaining three, are there any places where these are not continuous and differentiable? Well, let's see. What does the inverse sine curve look like? If I remember correctly, it looks kind of like this. And it maxes out at negative pi over 2 and pi over 2 and gets as big, and is defined from 1 to negative 1. Does that look continuous and differentiable on the interval from negative 1 to 1? Sure does to me, so that's a no good.
What if it were negative, become inverse of cosine?
Well, let's just, okay, C. So why are C and D, which look almost exactly the same, why is D, according to the answer and C not?
The book said so.
If you graph it, is there a corner on D?
I don't understand why it can be E. I don't understand why it can be E because, I mean, it wouldn't be differentiable at like 2, would it?
Right, but 2 is not in the interval that we're interested in.
You're right.
Which is,
He is a math teacher. You're right.
there we go. So here's our grapher. Okay, let's hit tab so I can redo it. Clear. And if we do x to the power of 3 divided by 5. Okay, let's see. It looks continuous.
Look good.
It looks differentiable unless there's a vertical tangent here.
Which there is.
Which there is. But what about x to the power of 5/3?
So you'd have to grab all of those?
Look good.
Well, certainly on the red curve, there doesn't look like a possibility of a vertical tangent. All right?
How do you know if it's a vertical tangent or not?
Because it looks like as we go up here and I'm doing sort of the tangent line thing, it looks like it goes nearly straight vertically.
Yeah.
Okay? But the big thing is, I think we can actually show that if f of x is equal to x to the 5/3, we get f prime of x is equal to 5/3 x to the 2/3. Whereas if I say g of x is equal to x to the 3/5, g prime of x is equal to 3/5 x to the negative 2/5. Okay, which means we got that thing in the bottom, which means when x is equal to 0, we've got a derivative that's undefined.
Big mama.
Big mouth. So the big thing that ends up causing trouble is the fact that the derivative is less than, the exponent was less than 1.
I understand!
The equation be 3 over 3 x times negative.
Drop the power down, reduce the power by 1.
But I'm thinking if you reduce it, subtract by if you subtract 5/5 from 3/5, I thought that would be different.
3/5 minus 1, which is 3/5 minus 5/5, which is something over 5. 3 minus 5 is negative 2. All right. All right, are we done? Yep, look up.
Oh, good. Look good too.